Hello, good morning. And this is our group poster. And for the background summary is a local food processing factory has recently incurred government fine for discharging with untreated wastewater directly into the neighbor river. As a commission environmental consultancy team, we have been tasked for reviewing current practice and proposing a comprehensive improvement plan to ensure regulatory compliance and environmental restoration. So the major cause of the problem is absence of treatment infrastructure, high organic pollutant, regulatory non-compliant, and ecological impact. And the key objective for this poster are the pollutant evaluation, which characterize the factory effluent to identify specific parameter exceeding the legal limit, and system. The second objective is system design, which propose a sustainable wastewater treatment technology that ensure 100% compliant with the government regulation. And finally, the third and final objective are strategic management, which develop a long-term compliance plan and community engagement strategy to prevent a future violation.
Okay, Assalamualaikum. My name is Muhammad Adili Kamili Bingham Sani. My normal message J22A013X. My part, the exploration analysis session. This analysis was conducted to assess the level of wastewater pollution and the effectiveness of the existing treatment system. Data was collected from three main points. First, effluent in the equalization tank. Second, dissolved effluentation (DEF) process. And third, effluent the membrane bioreactor (MBR) system. The main parameter analyzed were pH, chemical oxygen demand, and total suspended solid. Because these parameters are very important in determining compliance with Department of Environmental Standard. Based on the effluent data, the pH value was still within the allowed range, but the COD and TSS value were very high and exceeded the DOE standard. This indicates that the raw wastewater has a high content of organic matter and suspended solid and is not suitable for direct discharge into the river. In addition, when treatment was applied using the MBR system, especially the hollow fiber HF membrane, the reduction of COD and TSS was much more effective and met the DOE standard. In conclusion, this data proves that MBR integration is a critical requirement to ensure legal compliance and environmental protection.
Assalamualaikum, my name is Nurliana Hadira binti Trisno. My number matrix is J23A0579. So I will discuss about research for a solution for our problem. So the main issue in food processing factories is the discharge of untreated or partially treated wastewater into nearby rivers. This wastewater contains high level of POD, COD, suspended solid and fast oils, and grease, which reduce oxygen levels and harm aquatic life and public health. This problem is caused by outdated treatment system, poor monitoring, increased production without upgrading treatment capacity, and limited staff awareness. Therefore, the issue is not only technical but also involves organizational and management factors. In Malaysia, some factories in Selangor and Johor have successfully used dissolved air flotation combined with membrane bioreactor system. DAF remove fats, oils, grease, and suspended solid, while MBR reduce BOD, COD to meet DOE standard. Online sensors are also used for real-time monitoring, and treated water is reused for cleaning or cooling. However, these systems still do not achieve zero discharge. Internationally, Singapore applies advanced membrane technologies such as ultrafiltration and reverse osmosis to treat and reuse hot wastewater, reducing both water and energy consumption. Countries like the US and Germany also use advanced treatment and water use strategies. So for me, Malaysian factories can further improve sustainability by adopting advanced treatment, continuous monitoring, and water use approach beyond basic regulatory compliance. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Rabiatun Adawiyah. I'm going to explain about develop your solution plan. First of all, this solution starts with technical improvement at the factory level. The factory should install an on-site wastewater treatment system to treat wastewater before discharge. Screening removes large solids, anaerobic treatment breaks down organic waste, and aerobic treatment further cleans the water. Grease traps are important to remove oil and fats, which are common in food processing wastewater. After treatment, the water can be reused for non-drinking purposes such as cleaning or irrigation. Regular monitoring is needed to ensure that the treated wastewater meets illegal discharge standards. Number 2, policy and management approaches. Technical systems alone are not enough without proper management. The factory should establish internal environmental management policies to guide daily operation. Management can also apply for government incentive to support the use of green technologies. Continuous training is important so workers understand how to operate systems and comply with environmental regulations. Number 3, community-based approaches. Community involvement helps improve environmental responsibility and public trust. Environmental awareness programs and can educate the public about pollution prevention. River cleanup activities show the factory's commitment to protecting the environment. Number 4, implementation timeline. The plan is divided into short-term and long-term actions. In the short term, within 1 to 2 years, the factory should focus on installing pre-treatment units and training staff. In the long term, over 5 to 10 years, the goal is to develop a full wastewater treatment plant. Long-term plans also include promoting water reuse and achieving full compliance with environmental guidelines.